For this video, this is going to be part one of probably three. I'm going to go over questions 1 through 20 on the review for our Unit 3 test on derivatives. So again, my hope is that since I'm going to give this to you with over a week until our first day of the test, that you have enough time to put in the effort to figure out how to do these. So watch the video if you get stumped, but the hope is that you can try to do these without the video first. Okay, so let's start with number 1. It says, what is the average rate of change of y equals cosine of 2x on the interval of 0 to pi over 2? So to find the rate of change, all right, you're going to have the change in your functions. So this is going to be the rate of change is going to be the change in your function, so your y values, over the change in your x values. All right, so I'm going to plug in pi over 2 to this function. So 2 times pi over 2 minus the cosine of 2 times 0 all over pi over 2. Now, the first thing I notice is that this is going to be the cosine of pi, right? 2 divided by 2 is 1, minus the cosine of 0 all over pi over 2. So if you need to go to your trig formula sheet, I'll pull that up for us. But here is our trig formula sheet to find the cosine of pi. So cosine of pi, looking at our quadrantals, we have pi is -1 comma 0. So the cosine of pi is going to be -1, right? It's always the x value. So the cosine of pi is -1 minus the cosine of 0, right? That's over here. Cosine is in the x, and the cosine of 0 is 1 all over pi over 2. So -1 minus -1 is -2. So I have -2 divided by pi over 2, which is going to change to be -2 times 2 over pi. If you multiply straight across, you get -4 over pi. So that is our answer for number 1. All right, let's do number 2. Now, number 2 says, at x equals 3, the function given by this piecewise function is either undefined, continuous, but not differentiable. So really, this is a question about continuity and being able to find the derivative, okay? So the way that we talked about this in class, and this is a good opportunity to review this, but if you find that a function is differentiable, all right, if it is differentiable across this interval, in this case, in all your x values, then that means you're able to take the derivative at any point along these x values, okay? So if it's going to be continuous, right, that means that when I plug in 3 to both pieces of this, you should see that there's no discontinuity. So there's no like jump or removable discontinuity happening. I'll show you on Desmos to kind of confirm for your brain. To see that it's differentiable, I'm looking out for any type of sharp curves. If I see any sharp curves or the fact that it's not continuous, I'll know that it's not actually able to be differentiated. Okay, so my first step is just to plug in 3 for both pieces. So I'm going to plug in 3 squared and then 6 times 3 minus 9. So those are both pieces. And I'm looking to get the same values. That's 9. This is 18 minus 9, which is also 9. So that's kind of the first thing. So I know it's continuous. All right, so it's either going to be continuous, but it's not able to be differentiated, or it's continuous, and you can actually take the derivative at any of these values, okay? So I'm going to go plot this. So type it into Desmos and focus on my x value of +3. All right, so I have x is less than 3. And that's going to be x squared. And I have x is greater than or equal to 3. That's going to be 6x minus 9. Right? And again, I'm focusing on 3. 3 is right here. 3, 9, right there. And you'll notice it's continuous, right? There's no, you don't have to like jump to the next piece, so it is continuous. And also, I don't see any sharp curves or turns there, right? It is smooth, so that tells me that this is differentiable as well. So it's continuous and differentiable. Okay, let's go number 3. Number 3 says if we have this function, we want to find the equation of the line that's tangent to this graph for x equals 1. All right, so we've done this problem so many times, guys. The first thing you want to be thinking about is you're going to need point slope form. Okay, so that's on the formula sheet. I'll show you here in a second. Let me pull it up. So here's the formula sheet, and I put it right there. There's point slope form. So I'm going to plug in x is 1. So f of 1 equals 2 times 1 minus 1 to the 5th power times 1 plus 1. So 2 minus 1 is 1. 1 to the 5th power is 1. 1 plus 2 is 2. So that's 2. So my point is 1 comma 2. Now to find the slope, I need to take the derivative of this function. So d dx of 2x minus 1 to the 5th power times x plus 1, right, of all of that, and then plug in my x value of 1 to get the slope. Well, I notice a couple things here. I notice this is going to be the product property, and I have two things multiplied together. So I need to take the derivative of the first times the original second plus the derivative of the second times the original first. So the derivative of the first is actually going to involve the chain rule. So I put 5 times 2x minus 1 to the 4th power, but times the derivative of that inside, right, that 2x minus 1. The derivative of 2x minus 1 is 2 times the original second plus the derivative of the second one, which is going to be the derivative of x plus 1, which is 1, times the original first one. Okay, so I'm going to plug in, this is f prime of x. You could make it look nicer, but no reason to, because I'm just going to plug in 1. So 5 times 2 times 1 minus 1 to the 4th power times 2 times 1 plus 1 plus 1 times 2 times 1 minus 1 to the 5th power. Do a little math in my head, but you can always just type this into Desmos. 2 times 1 is 2, 2 minus 1 is 1, 1 to the 4th power is 1. That's 5 times 1 times 2 times 1 plus 1, which is also 2. All right, this other side is 1 times 2 times 1 is 2, 2 minus 1 is 1, 1 to the 5th power is 1. So my slope is going to be 20 plus 1, which is 21. All right, so now I'm using my point slope form. Y minus 2 equals 21 times x minus 1. Distribute, you get 21x minus 21. Move the 2 over by adding 2, and you get minus 19. So this is our answer. So the answer is B. All right, let's keep going. Number 4. It says in the xy plane, the line x plus y equals k, where k is a constant, is tangent to this graph of y equals x squared plus 3x plus 1. What is the value of k? Well, what I noticed is they gave me this tangent line not in slope-intercept form, so I'm just going to write it in slope-intercept form. So y equals negative x plus k, and I'll notice that the slope is negative 1. So we kind of just did this in the previous problem. But to find the slope, remember, that's when you plug in your x value into the derivative. So let's find the derivative of my original function. So d dx of x squared plus 3x plus 1. All right? So that's going to be 2x plus 3. So whenever I plug in, right, if I plug in some value, I don't know what it is, I should be getting whatever that value is, should be equal to my slope, which is negative 1. So I plug in, or sorry, if I solve for x, I get 2x equals negative 4, or x equals negative 2. All right? So I know that my x is going to be negative 2, all right, and I can find my y value by plugging that back into the original equation. So if I plug in y equals negative 2 squared plus 3 times negative 2 plus 1, I'll get 4 minus 6 plus 1, which is negative 1. All right, now that's not the answer. That's just my ordered pair. The answer is to find k, and it says k is the same as x plus y. So x plus y equals k. If I add those together, I get -2 plus -1 equals -3. All right, let's keep going. Number 5. Now, number 5 shows us the graph of f of x, which is a parabola, and a tangent line that's intersecting at this point 3, 4. All right, we want to find the value of f prime of 3. Now, we've talked about this in the last 2 problems, but if you plug in your x value, right, it's tangent at x equals 3. If you plug that into the derivative, that would give you the slope. So f prime of -3 would give me the slope of my tangent line. Well, I have the tangent line, so I just need to find the slope of this tangent line. So you can do it by counting. So I counted up 1 and left 2. So up 1, I'm going to do dotted. So up 1 and then left 2. So that's going to be +1 over a -2. So that slope is -1/2. All right, let's keep going. 6. We have the equation for the line tangent to this graph of a differentiable function f at x equals 2 is y equals 9x minus 12. So they've given us the tangent line. Which of the following statements, must be true? All right, now this is kind of playing off the last 3 questions. All right, the first thing I notice is that if we have the line is tangent, all right, the tangent line is at x equals 2, that means they will intersect. If I just refer to number 5 here, right, you'll notice that the function f of x and the tangent line to it have the same point, right, at 3, 4. So same idea here. If I plug in 2 into this tangent line, then that's going to be the same as if I were to plug in 2 into the original function. That's going to be 18 minus 12, which is 6. So f of 2 has to be 6. So I know that one is true. Now let's talk about the other piece. The other piece of this is that if you look at the slope of the tangent line, we know that if we were to plug in 2, right, this x equals 2 is where our line is tangent to. If I plug that into the derivative, I should get the slope. All right, and what is the slope of our tangent line? It says 9. So I know this third piece must be true as well. All right, the only one that I don't know if it's true, it could be true, is that the y-intercept is -12. That doesn't have to be true. That is the y-intercept for my tangent line. That doesn't necessarily mean that I'm intersecting there. So the ones that have to be true are 2 and 3. Number 7. All right, another one where I have to find the line that's tangent to the graph of the function f at the point passes through these 2 points. Then f prime of 1 is, all right, so again, the idea is this is finding the slope. Okay, so if I find the slope of my 2 points, then I'll find what happens when I were to plug in this 1 into the derivative. So the slope of the tangent line, if I use my slope formula, is going to be -2 minus 7 over -2 minus 1. So -9 over -3 is 3. So if I were to plug in 1 into the derivative, I should get this slope of 3. Number 8. All right, number 8 says, here's the function f 4x cubed minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of this at the point x equals -1? So just like we did in a previous problem, I need to use the point slope form. So I'm going to first find my point. So 4 times -1 cubed minus 5 times -1 plus 3. So that's going to be -1 cubed is -1, so -4 plus 5 plus 3. All right, that's going to be, too many pluses there, sorry about that. That's going to be 4. So my ordered pair is -1, 4. Now let's take the derivative of f of x, so d dx of 4x cubed minus 5x plus 3. That's going to be 12x squared minus 5. And if I plug in my x value of -1 into that derivative, I will get the slope of my tangent line. All right, -1 squared is 1. 1 times 12 is 12. 12 minus 5 is 7. All right, so y minus 4 equals 7 times x plus 1. Doing the algebra here. Then I get y equals 7x plus 11. So C. 8 is C. Number 9. Number 9 says an equation of the line tangent to the graph of y equals x plus cosine of x at the point 0, 1 is, so same process. I already have the point, so that's kind of nice. So I just need to do the derivative of y. So dy dx, or d dx of x plus cosine of x. The derivative of x is 1, and the derivative of cosine is negative sine of x. So that's 1 minus the sine of x. If I plug in my x value of 0, 1 minus the sine of 0, and go to my trig formula sheet, we have the sine of 0, right, which is over here. Sine of 0 is 0. So that's 1 minus 0 equals 1. So the slope is 1. Now, I recognize that the point they gave me is the y-intercept, so I can just write it straight into slope-intercept form. But if you don't recognize that, we'll do the work. So y minus 1 equals the slope times x minus 0. Distribute, and you get x. Move the 1 over, and you get x plus 1. So B. Number 10. All right, this one says we have the function f of x. Which of the following statements is true? All right, so I'm going to go into Desmos and graph this. I should let you know that whenever we're asking questions about differentiability with absolute value or any type of radicals, you want to be cautious. So I already know that the reason I put this on the review is I know something's going to be interesting going on. So I'm going to graph it, the square root of the absolute value of x. It's minus 2. Stay in there. I got that right. Yes. Okay. Now it says to look at when x is 2. Now I notice when x is 2, there is a point. It is continuous. Okay. But what I don't see, right, what I don't see when I look at it is I don't see any smooth piece here. And this, we kind of talked about this when we did lesson 3.2. But if you look at it, as I'm moving towards 2 from the right, we approach the y value of 0. But when I move from the left, I can't, right? I can't move towards it from the left. So this means that it's not going to be able to be differentiable at this x value. So the answer to this question is that it's continuous, but it's not going to be differentiable. So A. Number 11. Now, number 11 says, at which value of x is it continuous but not differentiable? So I'm going to go backwards. I'll start with E. All right. So the first thing I notice about E is that if I look here, it is continuous and it's smooth. So this one is not going to be right because it's continuous and differentiable at E. D, right, is not continuous. We actually jump from going from the left and then from the right. We have to jump. That's called jump discontinuity. So it's not continuous and therefore not differentiable. For C, it's continuous and it's smooth. So just like E, that's continuous and differentiable, so not the answer. B is not continuous, but for a different reason. This is called removable discontinuity, right? Because as we approach the from the left and the right, the limit exists, but because it's not defined there, it is removable, so that's not continuous. And then for A is our answer because it is continuous, but you see this sharp point that it creates? Whenever we have that sharp point, that means it's not differentiable. So you're looking out for that sharp point for not differentiable. All right, that's A. Okay, number 12. Number 12 might be my favorite one. So we want to figure out values for C and D so that this is continuous and differentiable, right? It doesn't say that we're continuous, but if it is differentiable, we know it must be continuous. So the first thing I do is I'm going to set cx plus d and x squared minus cx equal to each other, because these must be equal at x equals 2. So I'm going to replace x with 2. Clean it up a little bit. Get 2c plus d equals 4 minus 2c. All right, now if I solve for d, if I move the 2c over with subtraction, I get negative 4c plus 4. All right, that's out of the first step. So that's d equal to something with c. So step number 1 is done if they're going to be continuous. To be differentiable, that means as I look at the limit as x approaches 2 from the left, it must be equal to the limit as x approaches 2 from the right. So my steps 2 and step 3, or if you want to call this all the same step, is I need to find these limits. All right. So the first thing I'm going to do is find the limit as x approaches 2 from the left. So here's how you do this. This is where you take the f of x function, so cx plus d, subtract what happens when you plug into, which actually is the same piece, cx plus d, all over x minus 2. Okay? I'm going to pause for 1 second here. Okay, I made a mistake here. I'm sorry about that. When you plug in the function, or sorry, when you plug in the 2, I should have written down what I wrote down when I plugged in 2, which is going to be 2c plus d. All right, so now I'm going to distribute. I'm going to get cx plus d minus 2c minus d all over x minus 2. And this is slowing me down. Let me close that. There we go. All right, you'll notice that the d's are going to make 0. So I have cx minus 2c over x minus 2. And if I factor out the c, you'll notice that my x minus 2's are going to cross out. So the limit as x approaches 2 from the left is just going to be equal to c. Now remember, that piece, I'll use my highlighter, and some of you don't like it, so I'm sorry. But essentially, I'm saying that this piece here became c. So now I'm going to find the piece on the right. All right, do that again. So now I'm going to find the piece on the right, which is the limit as x approaches 2 from the right. All right, and the piece on the right is x squared minus cx. And then I'm subtracting the same thing that happened when I plugged in 2, which is the top piece, which is going to be 2c plus d all over x minus 2. I'm going to zoom in, distribute x squared minus cx minus 2c minus d over x minus 2. Let me close this out, maybe make it look a little nicer. Okay. Now I'm going to keep going, but I'm going to plug in d. So I'm going to replace, right, with this d equals negative 4c plus 4. You're going to see what happens when I replace d with that. And because it's the opposite of d, I'm going to replace it with positive 4c minus 4. So positive 4c minus 4 all over x minus 2. Okay, keep going. All right, and you're going to watch. I'm going to kind of put the things together to help me factor by grouping here. So I'm going to put the x squared minus 4 together because I know how to factor that. And then minus cx and negative 2c plus 4c is going to be positive 2c all over x minus 2. So if I factor by grouping, the first one is x minus 2, x plus 2. And the next one is going to be, I factor out a minus c times x minus 2. So you can see that they share, right? They share the x minus 2. So when I write that, it's going to be the limit as x approaches 2 from the right of x minus 2 times x plus 2 minus c all over x minus 2. So the x minus 2's cross out, and now I have the limit as x approaches 2 from the right is just x plus 2 minus c And if I plug in 2 for x, I get 2 plus 2 minus c. So I have that's equal to 4 minus c. All right, so that's my piece on the right. Let me highlight that. So essentially what I'm saying is that is the same as the limit as x approaches 2 from the right. So now I'm going to set my yellow highlighted piece, which is c, equal to my teal or turquoise highlighted piece, which is 4 minus c. I'm going to solve for c. All right, so moving the c to the other side, you get 2c equals 4, or c equals 2. So that's one of the pieces, but now I'm going to use this same equation for d to find what d is. So d equals negative 4 times 2 plus 4. So d equals negative 8 plus 4. So d equals negative 4. Now it doesn't ask for that. It doesn't ask like c is this or d is that. It says what happens when you add them. And when you add 2 plus negative 4, you get negative 2. Wow. Amazing. That is, you can see why I chose that as my favorite problem. Let's go to 13. Keep going. Number 13. Which of the following statements, if true, cannot be used to conclude that f of 0 exists? All right. So again, if we want to say that f of 0 exists, all right, if I look at D, right, the graph of f has a y-intercept. Well, I know that if it has a y-intercept, then it definitely exists. If it's differentiable, then it must exist. If it's continuous, then it must exist. So the only one that might not be true, or I should say, if it is true, cannot be used to conclude that the function exists at x equals 0 is A, because we just talked about, let me go back to this one here. Do you remember when I looked at point B, right? When you look at that x value of B, the limit from the left and the right as you approach x equals B is actually the same value, right? We're approaching that open circle, so the limit exists. But you'll notice that f of B does not exist, all right, is undefined because it has an open circle, right? So that has removable discontinuity. So this idea in number 13 essentially is saying that even though the limit exists, the value for f at that x value might not exist, right? That's the one that cannot be used to conclude. So 13 is A. Okay, 14. So it says, which of these is true about this piecewise function? So the first thing, whenever I get a piecewise function asking about continuity or differentiability, is I take a peek at, if I plug in the x value, do I get the same thing? So if I plug in 5 here, I get 5 squared minus 20, just 5. And this one, I get the opposite of 5 squared plus 20, which is going to be negative 5. So the fact that those don't match means that there's going to be jump discontinuity. And I'll go into Desmos and show you. But this is not continuous. All right. So I know that it's not continuous, and therefore it's not differentiable. All right. So 14 is A. Now let me go show you in Desmos how I kind of knew that, or at least show you a visual of it. All right. So I'm going to type in my piecewise function for x is less than 5. Make sure I got the right thing. Yes, and that's x squared minus 20, comma, and for x is greater than or equal to 5, we have the opposite of x squared plus 20. So negative x squared plus 20. If you notice, when I go to 5, you can see when x is 5, we have to jump, right? We jump from here down to the next one. So it actually does it as I scroll. So jump. All right. So it's not continuous. They don't connect. All right. So that tells me the answer is A. Let's go to 15. So 15, if f is the function given by this f of x, then find f prime of 2. So I'm going to find the derivative of f of x, which is d dx of 4 over x plus 5x minus 1. Now, one thing I notice is that I'm going to rewrite 4 over x as 4 times x to the negative first power. It's going to make this much simpler, and that means I won't have to use the quotient rule. If you want to use the quotient rule, feel free. It's on the formula sheet, but I'm going to use the power rule. I think it's a little simpler and more efficient. So we have negative 4x to the negative second power plus 5. That's the derivative. So if I plug in 2, I'm going to do negative 4 over 2 squared plus 5. Negative 4 over 4 is negative 1. Negative 1 plus 5 is positive 4. All right, let's keep going to 16. Very similar problem. I'm finding the derivative of 1 over x cubed minus 1 over x plus x squared. So the first thing I do is I rewrite that as x to the negative third power minus x to the negative first power, and I don't have to rewrite the second piece. So our derivative is going to be negative 3x to the negative fourth power. Now watch this. The negative 1 is going to come to the front, and it's already subtraction. So a negative 1 times a negative 1 is going to be positive 1, x to the negative second power plus 2x. So this is the derivative, and I'm going to plug in negative 1 where I see x, so negative 3 over negative 1 to the fourth power plus 1 over negative 1 to the second power plus 2 times negative 1. So anything to an even power is going to make it a positive, so that's negative 3. Same thing here, plus 1, and then minus 2. So the answer is negative 4. 17, we're oh so close. All right, so we have f and g are differentiable functions, and we have h of x is all this stuff together. What's the value of h prime of 0? So I need to find the derivative of h of x, so d dx of 3 times f of x minus 2 times g of x minus 5 times the cosine of x minus 3. Now this is nice because I don't have any chain rule issues. It's just taking derivative of each of these. You'll notice the first three, right? The first three functions have these constants in front. So if you use the constant multiple rule, watch how I use it. It's just going to be 3 times the derivative of f of x minus 2 times the derivative of g of x minus 5 times the derivative of cosine of x, which is negative sine of x, and the derivative of a constant negative 3 is just 0. So clean it up. That's going to be plus 5 times the sine of x, and I'm plugging in 0. So we have 3 times f of 0 minus 2 times f of times g of 0 plus 5 times the sine of 0. Using the problem, it says f of 0 is 3. It says g of 0 is 7. And I know that the sine of 0, all right, is 0. If you need to use the trig form of the sheet to look at the quadrantals, please feel free to do that. So this is going to be 9 minus 14, which is negative 5. 18. All right, it wants us to find the derivative of this function. So f prime of x equals d dx of, watch how I write it, the cosine of 4x to the third power. Okay? Now this is the chain rule. So you have 3 times the cosine of 4x, now watch this, times the derivative of cosine, which is negative sine of 4x, not done yet, times the derivative of that inside, which is the derivative of 4x, which is 4. So you clean this up. Oh, I'm sorry, I missed a step. My bad. When you use the first part of it, it's 3 times the cosine of 4x, and that should have been squared. That's my fault. Okay, so now if I clean this up, I get negative 12 times cosine squared of 4x, come on, times the sine of 4x. All right, so if I match it up, my answer is going to be B. 2 more, so close, 19. Now these two are going to ask us to look at the derivatives of the exponential function, all right, which I did not do the lesson on purpose. It's on purpose. I didn't do it because it's really not that tricky. I put it in the formula sheet, so I'll open the formula sheet for you. So that way you know that you're going to be able to refer to it right here. So let me show it to you. And we'll practice in class, don't worry. So it's down here near the end. the derivative of the exponential function, all right, with the e, which makes it a natural exponential function, is right here, which is you just copy it down, and then you take the derivative of whatever is in the exponent. All right, so we'll practice that with many of these review problems. This is not the only two that has it. All right, so let's first find, since I need to find the derivative, I'm going to find the derivative of f of x, which is d dx of e to the x. So here's how it works. You first just copy down whatever this is, right? So it's e to the x. If it said e to the 6x or e to the negative 8x, just copy that down, times the derivative of whatever's in the exponent. X is in the exponent, so the derivative of x is just 1. So this is actually just e to the x. It won't always be that simple. So this problem says to find the natural log of f prime of 2, which is going to be, if this is f prime of x, I'm going to replace that x with 2. So e to the second power. And now it becomes a question that you would have done last year in pre-calculus. Here's another way to write it, is e to the second power, right? The base of a natural log is always the base number e. If you don't know it from here, that's fine. You can use a power rule you talked about in pre-cal, which is 2 times the natural log of e, and the natural log of e is just 1. So 2 times 1 gives you 2. Last question, number 20. And don't worry, there'll be other parts, obviously, to finish the rest of the review. We have f of x equals 2 cosine x plus 3 times e to the x power. What is f prime of 0? So let's find the derivative. d dx of 2 times the cosine of x plus 3 times e to the x power. All right, so this is just a constant multiple, so 2 times the derivative of cosine of x, which is negative sine of x, plus 3 times, right, just a constant multiple. Here's the derivative of e to the x. So it's e to the x times the derivative of x, which is 1. So we can clean that up and get negative 2 sine of x plus 3e to the x power. Plugging in 0 gives me negative 2 times the sine of 0 plus 3 times e to the 0 power. We've done sine of 0 many times now, so sine of 0 is 0, so that's just going to be 0. And anything to the 0 power, even if it's e, any base to the 0 power is 1. So that's going to be just 3. So 0 plus 3 is 3. All right, and that's it for the first 20. So hopefully you've had a chance to practice a few of these and come on back for the next parts.